Hello guys, welcome to the second and the final lesson on limits. First of all, let's review what we learned last time. A limit is a set of value that a function approaches as the value of its variable approaches a specific number. To find the limit, you can use a direct substitution method where you plug in the value that the f of x is approaching into the f of x. If the function is a polynomial function or a rational function, and a is in the domain of the function, then the limit as x approaches a of f of x is f of a. Last time when we looked into the form called indeterminate form, where when you directly substitute the value that the limit is approaching to into the limit, you get an undefined answer. And last time we learned how there is 3 ways to approach limits with indeterminate form. You can approach it algebraically, numerically, or graphically. Algebraic method involved you factoring and simplifying the function. The numerical method involved you typing in the function into the calculator and using the table function to look at where the value approaches. The graphical method involved you plugging in the equation into the graphing calculator and looking at the graph to figure out the limits. We also talked about how there are 3 different cases where the double-sided limits fail to exist. Number 1, when the function approaches a different y value from the left or from the right, as shown right over here. Number 2, as f of x increases or decreases without bound as x approaches a basically vertical asymptote. And 3, f of x oscillates between the 2 fixed points. It moves up and down between the 2 fixed points. So today we're going to learn something called a one-sided limit. This limit is a value that a function approaches as the x approaches a from single side only one side, either from the right or from the left. So right-handed limit is a limit that when the function approaches from the right, and this is the notation for it. If you look at it, everything is very similar to the double-sided limit notation except for this plus. If there's that plus, it's an indicator that it's a right-handed limit. So there's an example. So limit of x approaches a of the absolute value of x over x minus 3. If you plug in 0 into this equation using the direct substitution method, you'll get the indeterminate form of 0 over 0 minus 3. But if you graph this function into the calculator, then using the graph, you can clearly see that the function approaches negative 2 from the right, which makes the right-handed limit of this function negative 2. The left-handed limit of this function, the left-handed limit is the limit of the value that the f of x approaches from the left, and you can see that the notation uses the similar notation except for the minus on the top, and using the same function, you can see how the value is approaching negative 4 from the left, making this left-handed limit negative 4. So the answer of a one-sided limit can be a value like it was shown above, but it may also be positive or negative infinity. So looking at the example on the right, you can see how as the graph approaches negative 3 from the right, it approaches infinity. Because it's a single-sided limit, the answer can be as the limit of x approaches negative 3 from the right, the limit is positive infinity. If it approaches from the left, it's clear that it's going to approach negative infinity. Note that one-sided limit can approach limit infinity, but two-sided limits can't unless both left and right approaches the same infinity. Basically, this means that 99.99999% of the times, double-sided limits will not be an infinity. So there's another type of limits called infinite limits. If limit of x of x as it approaches a from the right or from the left is positive or negative infinity, then x equals a is a vertical asymptote. Look at the example right over here. So let's use the direct substitution method first. Oh, it gives us an undefined answer. That means that it must have a vertical asymptote in this case, right over here. Now, let's see what the one-sided limit of this function is. So you graph this function into the calculator and you'll see how from the right it is approaching positive infinity and from the left it's approaching negative infinity. So limits at infinity. So if limit of x approaches infinity of f of x is equal to b, or limit of x approaches negative x of f of x is equal to b, then x equals a is a horizontal asymptote. There are three ways to determine the horizontal asymptotes using limits. If the f of x is a rational function with a numerator with the same degree as the denominator, then the limit of the x approaches infinity of f of x is the ratio of the coefficients of the largest degree in the numerator and the denominator. Doesn't this seem familiar? Yes, this is the rule that we use to find the horizontal asymptote in the precalculus rational function unit. So, in this case, let's look at the example. So we can see how the limit is approaching infinity, and the numerator and the denominator has the same degree. Then we'll use the ratio of the highest degree in the numerator and the denominator. So let's look at the coefficient for numerator is 1. The coefficient for denominator is 4, so the ratio must be 1/4. So the limit must be 1/4, and the horizontal asymptote is 1/4 for this function. Another one is when the rational function with a numerator has a higher degree than its denominator. Then the limit will be either plus or minus infinity. So if you look at this function, as the limit approaches infinity of x squared plus 3 over x minus 3, it is equal to infinity. Why? The numerator has a higher degree than the denominator, so you know that the function is going to approach infinity, and if you plug in values higher and higher, you'll see how the number becomes higher and higher. However, in this case, when the limit of x approaches negative infinity of this function, then using the denominator rules, you know that it's going to be plus or minus infinity, and if you plug in values that are smaller and smaller, then you'll see how the value decreases, which is an indicator that this function is going to have a limit of negative infinity. Also, lastly, there's if a function is a rational function with a numerator with a lower degree than the denominator, then the limit of x approaches infinity is equal to 0, as is shown over here. If you look at this right over here, the limit of x approaches infinity of x plus 5 over x, 9x to the 7th power minus 8 is equal to 0, because the numerator has a smaller degree than the denominator. There may be some limits that look like this. In this case, you may just take the square root of the highest degree on the numerator, because that's a square root on the top. And this will not really affect the answer that much, because the limit of infinities approaches such a big number that changes and like the plus 1 won't do that much. So if you take the square root, you will get limit of x approaches infinity of x squared over 7x squared, which is 1/7. This is the final slide for today, and this is the end of your limits unit. Thank you for listening to me, and let's see you next week.